Hi there, my name is Dimitris, and in this video we will continue our series on binomial expansion, and this time we will deal with what we call general term in a binomial expansion. So far, I should remind you that we have seen in previous videos how to expand a binomial by using either the Pascal's triangle or the formula of that expansion, and then how to simplify that expansion by applying combinatorial numbers, by applying properties of powers. Now, we will learn a quicker way to do the majority of the exercises. But in order to understand what the general term stands for, we should start by the formula and by the expansion of a binomial. So, assuming that we have this binomial, a plus b to the power of n, and we know that if we want to expand it, we should be writing this. N choose 0, a to the power of n multiplied by b to the power of 0, plus n choose 1 times a n minus 1 b to the power of 1, plus n choose 2 a n minus 2 b squared, plus n choose 3 a n minus 3 b cubed, plus up until we end up to n a 0 b n. That would be the proper expansion. Now, let us notice, however, that all of the terms of this expansion have some common things. First of all, in all of them, n is up there in the combinatorial number. All of them have the product of a and b. Now, let's see the differences. The only difference is with regards to the value of the rest. But here we can see that whatever we have here, the same is up there, and here we have what is missing from n. Whatever we have here, the same we have as a power of b, and here we have n minus that. Whatever we have here, we have as the exponent of b, and here we find the difference of that from n. So by assuming that down there I should have, let's say, r to represent that value on its time, up here I should also have r, and here I should have the difference from that of that from n. And this is what we will call general term. General term of a binomial expansion a plus b to the power of n. For example, let's find the general term of 2x plus 1 to the power of 5. It should look like 5 choose r, 2x to the power of 5 minus r times 1 to the power of r. Let's work with the general term of 1 minus x to the power of 4. That should be 4 choose r times 1 to the power of 4 minus r times negative x to the power of r. The general term of x squared plus 1 over x to the power of 3. That should be 3 choose r, x squared, 3 minus r times 1 over x to the power of r. This is how we form the general term. Let's see now some applications of that term. First of all, by looking again on the things that we started with, we can see that the first term was obtained for r equals 0. The second term of the expansion was obtained by going to the general term and substituting r equals 1. The third term was found by going to the general term and substituting r equals 2. So in total, or in general, in order to find the nth term, we should go in the general terms expression and substitute instead of r the n minus 1. And there will be some exercises, either we're doing the IB or the AP program, or whatever we actually do, in which we will be given a binomial expansion and we will be asked to calculate a specific term. In this case, we should only consider the general terms expression and substitute the proper value that will produce that term. Let's see some examples. And let's call that finding directly a specific term. For instance, let the 2x plus 3 to the power, or let's not do that, plus 3. Let's make numbers easy enough. To the power of 5. Find the third term in that expansion. Okay, solution. Let's begin by formatting the general term. That should be 5 choose r, 2x to the power of 5 minus r times 1 to the power of r. Since we want the third term would mean substitute r with 2. By doing so, we would get 5 choose 2, 2x to the power of 5 minus 2 multiplied by 1 to the power of 2. Now the rest is details, or basically the rest is doing operations. 5, 2, we can either use the GDC or we can use the Pascal's triangle or the formula. I kindly remind you that 5 choose 2 with regards to the formula is 5 factorial over 2 factorial times 3 factorial. This can be expressed as 3 factorial times 4 times 5 over 2 factorial times 3 factorial. They are cancelled out. 20 over 2 is 10. So that would be 10 times 2 cubed times x cubed times 1. So in total, that should be 80x cubed. That's the third term in the expansion of 2x plus 1 to the power 5. So in general, that's the easiest thing, the easiest scenario we can actually work with. We are given a binomial expansion. We should know from now on how to form its general term. We do want the first term, substitute for r equals 0. We want the fourth term, substitute r equals 3, and so on. Let's move to other examples or exercises in which we are asked to find a specific term, the order of which is not known. What do I mean by that? In the previous exercise, we wanted to find the third term, the fourth term, the second term. This meant that we wanted to find a term of a specific order. Here, we simply want the term. Let's see what I mean by that. We have 5x plus 2x to the power of 5, and we are asked to find the term of x, the term that contains the... What's the difference here? We don't know which combination, which term with regards to order that term will be. I mean, will it be the first term? Will it be the second term? The fourth? We have no idea. We were not given any such info. In this case, we should, let's learn that as a methodology, we should always begin with the general term. So let's do that. The general term of that is 5 choose r multiplied by 5 over x to the power of 5 minus r multiplied by 2x to the power of r. Next, we want to do operations. Do operations, and mostly by operations we mean properties of powers. Properties of powers. Here, the two properties that will be needed are a over b to the power of n equals a to the power of n over b to the power of n, and ab to the power of n is an bn. Let's apply them. 5 choose r remains as it is. 5 to the power of 5 minus r over x to the power of 5 minus r multiplied by 2 to the power of r times x to the power of r. Then we should rearrange the terms so that all those that do not have any x move in front. What are these? This, and that. So let's rearrange them so that these move in front. 5r, 5 to the power of 5 minus r times 2 to the power of r times x to the power of r over x to the power of 5 minus r. Then we should combine the x's again by certain powers, again by certain properties of powers. This time we will use the property that states that a to the power of n over a to the power of m is n minus m. So I'm going to have to repeat all that. 5 minus r times 2 to the power of r times x, r minus 5 minus r. Let me rewrite that in a more clear way. 5 minus r, 2 to the power of r, x, r minus 5 plus r. So again, in an even clearer way, 2r x 2r minus 5. Now that we are done, we should compare this with what is needed, meaning that we want to find x, the term that contains x. And we have so far found that any term looks like that. The only difference between any term is the value of r. So in order to achieve x, in order to achieve x, I need the x to the power of 2r minus 5 to be equal with x to the power of 1. So this means that 2r minus 5 should be equal to 1, which means that 2r should be equal to 6, so r should be equal to 3. And there is our answer. There is a last step that apply this value in the simplest form of general term. By simplest form of general term, I mean the one that I underlined with yellow. So for r equals 3, I should have 5 choose 3 multiplied by 5 to the power of 5 minus 3 multiplied by 2 cubed x to the power of 1. Of course, we would need some calculations here before we show that 5 choose r is actually equal to 10 times 5 squared times 8 times x. 5 squared times 8 is 200 times 10, 2000x. So this is the entire term we were looking for. In case some exercises simply want the coefficient of x, we would have responded back with just the numerical value of this term, which is, in this case, equal to 2000. We will do another example as well, but remember, let's see the steps again. We begin with the general term. Once we have that general term, we try to work on as many operations, which are basically properties of powers, we can, so that we can eventually bring that general term into the simplest possible form, which is the form in which everything that does not include x and therefore is considered to be a number moves in front, and everything else, which includes x, moves at the back. Once we have that simplest form of the general term, we have to compare it with what was that we were looking for. Were we looking for the term containing x squared, for the term containing x, for the term containing x to the power 5? We should compare that variable part, which includes expressions in terms of r, with what we want. From there, we should find the value of r, and the rest is applications. Let's see a second example, and this time we will do that quicker. 5x. No, it's not that. It's 3x plus 2 over x squared, and all that to the power of 6. Let me write that in a more clear way. X squared. We need to find the constant term. First of all, let's understand what constant term is. Constant term is the term that contains no x parts. Basically, by constant term, we mean the number. It's the number. To obtain it, I should search for the x to the power of 0, simply because since x to the power of 0 is 1. So we will go over all that methodology we showed in details before, in this case, to calculate x to the power of 0. Let's begin with the general term. So it should be 6r, 3x to the power of 6 minus r, multiplied by 2 over x squared to the power of r. Next, we should continue with operations. 6r, here we would need to apply this property. ab to the power of n is a to the power of n multiplied by b to the power of n. So 3, 6 minus r times x, 6 minus r. For the next part, we should apply that property. A over b to the power of n, a to the power of n over b to the power of n. So 2 to the power of r over x to 2r. Next, we should do some rearranging of terms. All those that do not include any x should move in front because they are simply considered to be numbers. And then we are left with the variable parts. I'll have to do some more operations to simplify them all. So that should be 6r, 3, 6 minus r, 2 to the power of r times 6 minus r minus 2r. Let's simplify it even more. 6r, 3, 6 minus r, 2 to the power of r, x, 6 minus 3r. And that's all. I have the simplest expression for the general term. Now, since I want the constant term, I now need to compare it. Constant, as I said earlier, means x to the power of 0. So this means that x to the power of 6 minus 3r should be equal to x to the power of 0, which means that 6 minus 3r should be 0, which means that 3r should be 6, so r should be equal to 2. And there it is. Finally, we should apply it. For r equals 2, I get 6 choose 2, 3 to the power of 6 minus 2, 2 to the power of 2, x, 6 minus 6, that's why that is 1. And all we have to do now is applications. Let's do this time the combinatorial number of 6 choose 2 with the Pascal's triangle, to remember that. 3, 3, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20. I don't need anything more. This should be 6, 0. This should be 6, 1. This should be 6, 2, 15. 15 times 3 to the power of 4 times 4. So that should be 60 times 81, whatever that is. That was all. I hope from now on, of course, it needs practice, but it's not a non-doable methodology. Okay, remember, find the general term, do properties of powers, bring it into the simplest expression, compare the x's. That's all. If you have any questions, if you have anything that you need to clarify, anything more, always feel free to leave your comment and your question below the video. As always, thank you for your time.